So, good afternoon, everybody. I will start with a small introduction, and then I will briefly review the solution existing for AR/MR applications focused on the problem of the color. And then I will describe some results we obtained recently using this new type of color converters. Okay, so let's get started. So as an introduction, I think all you know that MicroLED is very interesting for next generation display. For what we call large area display or direct view display, it will bring higher brightness, large color gamut, so definitely better image quality. But this is in the area of micro display where MicroLED will, gallium nitride MicroLED will bring the best advantages, mainly for the reasons of the not only high but very high brightness, as I will show, but also combined with a small pixel pitch. So I will begin with a kind of status of what are these constraints for this new kind of display, and what are the existing solutions. So the applications is mixed reality, augmented reality. So in this case, as you know, we have a digital image with, we have a digital image which is added on top of the real world. So for this, we have a very special system, which is called an optical see-through systems. These systems should provide a bright image, definitely, but also a wide field of view, and in the meantime, should be compact. I hope in the coming years, we will have such very compact systems as this glass, okay? If we focus on the micro display side, of course, we need not only high, but very high brightness. To give numbers, we estimate that we should obtain something like 100 kilonits or even 1 million. So this is huge. So definitely only the gallium nitride micro LED will provide this. Since it is an emissive display, it will be, by the way, also very compact. We need, of course, very good image quality. The first topic is resolution. We need the highest resolution. So since we have a small device, the consequence is that we need a very small pixel pitch, typically 1 micron or even less. We need excellent colors, definitely. So excellent colors means very good color gamut. But there is one specific constraint when we consider this application, because we mentioned high brightness, so we mentioned high power, so we mentioned temperature. So one particular constraint for these materials used for this device is we need a very high stability and very high power. Okay, so what is the status today? Of course, everybody considers that native color is the grail for MicroLED. So there are solutions coming, still in the research level. Strong progress are made, but definitely we all consider that it will take some years to achieve a commercially available solution. So therefore, for today and for the medium short term, we consider that color conversion is the solution, namely to use the blue LED pumping a color converter into green or into red. Okay, so definitely for these color conversions, quantum dots are very widespread today. So the color of quantum dots can be tuned thanks to the size of the particle. The smaller the particle, the smaller the wavelength. So we can obtain blue to red. We have a good color gamut thanks to this quite narrow emission spectrum, also together with fast response and high efficiency. Also, it is a very mature technology because it is used for many years on the LCD for, as you know, the LCD backlight. However, there are two particular things we need to highlight. First of all, the absorption in the blue light, the pumping light, is relatively moderate, typically 1 to the 3 to the power of 3. So the consequence that we need something like 5 to 10 micron thick layers to absorb all the blue light and to convert it into green or into red. Okay, so we imagine that if the layer is thick, it will be difficult to pattern the pixels in a small size. So typically the state of art today is something like 5 microns. Definitely this is not sufficient to address AR